Another aspect to sampling comes in the planning prior to sampling. Not only should we be mindful of the validity, but also the method under which the data is collected. Collecting bad data is wasteful and corrupts the decision-making process. There are many cautions you should observe. Steer clear of emotional bias relative to targets when collecting data. Avoid unnecessary rounding. Rounding often reduces measurement sensitivity. Maintain order for time sequence data. Some products are known to change over time. Record your measurements as soon after manufacturing is complete as possible. Most statistical inferences are grounded in the normal distribution. If your data does not exhibit enough resolution, this could be problematic. Make sure to screen data to detect and remove any data entry errors. Only remove data when there is a valid reason to do so. For example, using a box plot to find outliers. Make sure to qualify your data by including the time, machine, auditor, operator, gauge, lab, material, target, process change, and other conditions along with the data. In today's business environment, collecting data is costly. To ensure that the collected data is related to the problem, careful planning is needed such that the data collected is what we expect. Manual data collection requires forms and an understanding of how to properly complete. Check sheets, tally sheets, and checklists are data collection methods which are widely used. Other data collection methods include automatic measurement and data coding. We have discussed the role of data collection plans when considering qualitative data. From a quantitative standpoint, many of the steps are aligned, but there are some differences. First, formulate a clear statement of the problem. Next, we must operationally define precisely what it is to be measured. As part of this determination, list all the important characteristics to be measured. Make sure to select an appropriate measurement technique. Often, the means we use to measure the parameter is not suitable. Collecting data automatically is preferred, but if we must collect data manually, design your data collection form to be easily used. Make sure to also tailor your design to the individuals who will be collecting the data. Select an appropriate sampling method. Finally, determine who will analyze, interpret, and report your results. There are many things in our culture that occur seasonally. For example, Christmas. Seasonality can occur periodically or at irregular intervals. Time series plots are useful in helping us uncover the patterns to seasonality. Once we understand the pattern, we can best plan for the collection of data. Collecting and analyzing seasonal data can help us better forecast as well as localize and identify the magnitude and strength of the seasonal surge in the data. In other words, we are able to separate regular activity from seasonal activity. We can even use algorithms to dismiss the seasonal factors in the data to best understand the true performance of the process. Because the data comes in surges, how we analyze the data must be carefully considered. Exponential smoothing models are useful tools for analyzing seasonal data. Data can be collected manually or automatically. Manually collected data systems are labor-intensive and subject to human errors in measuring and recording the correct values. Automatic data collection systems include electronic chart recorders and digital storage. The frequency can be set to any sequence desired based on a set time interval or based on events. Automatic systems are very expensive and therefore have long lead times to implementation. These systems have highly accurate rates and can operate without human involvement. Automatic gauging can have multiple benefits to the organization. Some notable benefits of automatic gauging or digital visual systems includes the ability to easily sort product, error-proofing a process, detection of foreign matter or flaws, creating CAD layouts, creating prototypes, and high-speed inspection. The efficiency of data entry and analysis is frequently improved by data coding. Coding can make it more efficient and effective to record defects. This increases throughput and lowers anxiety when seeing multiple instances of the same issue. The issue description is replaced with the numerical code. Coding can take many forms and should be based on the capability and comfort level of the organization. Some common formats include coding by substitution, coding by truncation, coding by repetition. In all three of these methods, a longer and more complex entry can be shortened and simplified. For example, reporting a value in decimal form could be replaced with an integer form, acknowledging that the decimal could be ignored, missing, or misread. Check sheets are great tools for organizing and collecting. Check sheets also give us a physical record of process activity and performance. More data leads to understanding, better decisions, and faster resolution of problems. There are two main types of check sheets: a recording check sheet and a checklist. A recording check sheet is used to tally countable data. A checklist is more informative, like a setup sheet for a piece of equipment.